So we're going to look at the data as measured. So this plot down here is just plotting in 2 dimensions the category of the flower into either Virginica, versicolor, or setosa. The setosa is the one in the upper left-hand corner, the dark blue one. That's the one that's easiest to classify. The Virginica and the versicolor are mixed in with one another, and those are the hardest to classify. So first we're going to do linear discriminant analysis. So we'll use the LDA code to do this. It looks more or less like this, which looks about as the same as the logistic analysis code. So this is doing the analysis with the sepal length only. So this is the 150 by 2 array of sepal width and length. This gives us a model accuracy score of 0.8. And what we're going to be focused on is how do we interpret things like this 0.8, how do we look at the data, and then particularly if we were trying to decide between linear and quadratic discriminant analysis. So that score of 0.8 is almost identical to our logistic regression method that we'd looked at before. So here I just run the logistic regression and compute the values here. Let's see visually why these might differ. If you look at the left plot, that's the logistic regression, and on the right-hand side, it's the linear discriminant analysis. The logistic regression has a diagonal line that's sort of separating out the Virginica and the versicolor. You can see that there's a clear line separating those out, and then it also has another diagonal line, in essence, that separates out the setosa. So those are the decision boundaries for that. For the linear discriminant analysis, we can see that there's an almost vertical line that separates the versicolor and this Virginica. Again, the setosa is separated as well by a different diagonal line. So now let's use both the sepal and petal information to do the classification. So now we have twice as many factors, 4 factors for the classification. We now get a score of 0.98. This is a huge improvement. Let's take a look and see visually what's happened. So we're looking at our data over a 2D visualization, but we've really classified it over 4D. But what we see here is that we now actually can classify things that are sort of in the middle of this region, and we're just projecting that 4D classification onto this 2D space. So it's hard to completely understand why that's occurring, but we basically see that we're getting better at our classifications for that.